Okay, here in example 2, we're going to practice working with inverse functions and compositions, which means we're going to have expressions inside of expressions. And so the two key things to remember here is that you always want to work from the inside out, so looking at the inside first and then working your way to the outside. And then secondly, and perhaps, the trickiest thing about this is to remember the domain and range restrictions on these functions. And so let's look at example 2, letter A here. We've got tangent of the arctangent of -5. And you might immediately think that that is just going to cancel and the answer will be -5. And I'm going to tell you that the answer is -5, but you have to double check first, because there are times when you have tangent of arctangent of some number, but it does not end up being the same value. And so you have to double check it here. And because -5 is not a unit circle value, I'm gonna have to draw a picture here. And so that's what I'm going to do. I'm gonna start by drawing a triangle. And so because I know that arctangent of a negative has to be in quadrant 4, I'm going to draw an angle here in quadrant 4 and put my angle here. Now, if I draw a perpendicular back to the x-axis, this is going to create a right triangle. And when I say arctan of -5, or tan inverse of -5, what I'm saying is make the tangent of the angle equal to -5. Well, what do I know about tangent? I know that it's opposite over adjacent, and really you could think of -5 as being -5 over 1. And so if I put all of this down onto my triangle, the opposite side is going to have to be -5, and so that would be here when you're talking in relation to the angle. Here's the angle, and here is the opposite side, and then the adjacent side is going to be 1. And so I'm going to put that up on top since that is the adjacent side. And so now what I want to do is I want to basically find what the tangent of this angle is. And so if I do the tangent of this angle, then that's going to be opposite over adjacent, and so -5 divided by 1 is going to equal to -5. But again, you're gonna want to double check, because it does not always turn out to just be the number whenever these two functions are the same. It does not necessarily always just equal to that number. You're going to have to double check by drawing a picture, as long as it's not a unit circle value. If it's a unit circle value, for example, sine of pi over 6, you can just evaluate that. You know what that is. We don't know what arctangent of -5 is unless we use a calculator, and we're interested right now in learning how to do this without a calculator, and so therefore you have to draw a picture. And so this problem right here is a great example of what I was just talking about on letter A, that just because you have arcsine of sine doesn't mean that those are going to cancel out and that the answer is going to be 4 pi over 3, because as you see here in a minute, the answer to this question is not 4 pi over 3, and so you've got to investigate even when you see those two things that you think are going to cancel out. So what I'm going to do here is I'm going to start on the inside and work my way out. And so I start on the inside where it says sine of 4 pi over 3. Well, we learned how to evaluate this in section 4.1 through 4.3 when we learned our unit circle for the first time. And so if we just start by evaluating what that is, remember that I need to know, first of all, what quadrant it's in. And so 4 pi over 3 would really be the same thing as 1 1/3 of a pi. And so therefore, if this is pi, every angle starts here at 0. This is going to push me past the negative x-axis and into quadrant 3. Not quite into quadrant 4, because quadrant 4 would have to go past 1½ pi, and 1⅓ is smaller than 1½ And so what this means is that because of my acronym, All Students Trust Castle, that means that in this particular quadrant that we're in, sine is negative. Okay, the next thing we want is the reference angle, which is pi over 3. And so the next thing we need to know is what sine of pi over 3 is. And we know that that is square root of 3 over 2. And so this is going to be negative square root of 3 over 2. And so that's what's going to go over here into my parentheses to replace what I highlighted in yellow there. And so now what this is going to do is it's going to revert back to what we did in example 1. And so arc sine now of a negative number, I know the answer then is going to be negative, and the reference angle that we need is pi over 3. So again, just real quick, notice that just because I had arc sine of sine, that doesn't mean those just cancel and that the answer is 4 pi over 3 because of the domain and range restrictions that we talked about. Okay, here we want to figure out what sine of the arctangent of negative root 3 is, and so just working from the inside out here, that means we need to figure out what arctangent of negative square root of 3 is. And so I know that the answer here is going to be negative because it's arctangent of a negative, which will put it into the fourth quadrant. And the reference angle to make tangent equal to square root of 3 is going to be pi over 3. And so this is going to become the sine of negative pi over 3. Now, we have not done a ton of negative angles yet, but if you'll remember back to our 4.1 through 4.3 notes, we said that negative angles rotate in the clockwise direction. And so if I were to draw a picture here, this is still 0, and rotating pi over 3 in the clockwise direction is actually going to put me here into quadrant 4. And then just analyzing using my acronym, I know that sine is negative in that quadrant. And so this is going to end up being negative. The reference angle will be pi over 3, and sine of pi over 3 is the square root of 3 over 2. And so the answer to this problem in whole would be negative square root of 3 over 2. Okay, in letter D, the thing that we want to figure out first of all is what sine inverse of 1/2 is going to equal to. And since that's a positive 1/2, I know the answer will come from quadrant 1. And what angle in quadrant 1 has a sine value of 1/2? Well, that would be pi over 6. And so therefore over here, this is going to say cosine of pi over 6. And now applying cosine to pi over 6, cosine of pi over 6 is equal to positive square root of 3 over 2. Okay, once again, we see an example here of cosine inverse of cosine, and your natural inclination is going to be to cancel those out and just put 7 pi over 4. And I have to tell you, unfortunately, you would be wrong on this particular example, just like you were wrong on letter B a little bit earlier. And so what we're going to do is we're going to work from the inside out. This is going to be cosine of 7 pi over 4 first. Well, 7 pi over 4 I know is the same as 1 3/4 of a pi, which means that that angle is going to be in quadrant 4, which means that this answer is going to be positive since cosine is positive in quadrant 4. And so now the reference angle being pi over 4 means that this is going to be the same as cosine of pi over 4, which I know is the square root of 2 over 2. And so now this is going to become cosine inverse of the square root of 2 over 2. And so now we're asking ourselves, what angle in quadrant 1, because I know that if it's cosine inverse of a positive, the answer has to come from quadrant 1. What angle in quadrant 1 has a cosine value of square root of 2 over 2? And from our table, that would be pi over 4. And so again, notice that that is not just that number right there, that the number changed again because of the domain and range restrictions on these particular functions. Okay, last one like this, and then we'll finish up with more where you have to draw a picture. And so again, working from the inside out here, cosine of pi over 3 is what we want to put first. And so cosine of pi over 3 we know is equal to 1/2. And then arcsine of 1/2, well, I know that the answer is going to come from quadrant 1 since it's arcsine of a positive number. And so the angle in quadrant 1 that has a sine value of positive 1/2 is going to be pi over 6. And so the answer in full here is pi over 6.